Hello and welcome. We are from group number this. Our project is on bank loan prediction. Now, these are the members in our group. The data set we are working on has 5,000 rows or 5,000 instances. The source of our data set is a bank called Theras Bank, which has a campaign, and we got the data set from that campaign. Now, we can see the columns or features in a particular dataset. Also, to note that in our dataset, the loan acceptance rate is 10%. So 90% of the are not accepted. Now, for pre-processing, we have chosen these three methods. The first, we need to execute feature exclusion. We need to basically remove features that are not important. Now, if you see the columns or the features in our data set, we can see that customer ID has no value or no input when it comes to predicting that our particular customer will get loan or not. As a result, we are removing that particular column. So we are removing the ID column. So next, we need to handle the null and categorical values. We can see the we can find out the null values. We can see that if any columns have null values or not, then we have to remove the null values, or we can basically impute the null values and put manually a value in those null values. We have to also handle the categorical values, because machine learning models cannot work with text data, and categorical values are basically text data, and as a result we need to convert this text data into numbers, so that our machine learning model can understand. Finally, we need to normalize this, because we are using models like KNN, which won't work without normalized data. As a result, we have used standard scalar as our normalizing technique to normalize the data. Finally, before starting, we are splitting the data set. We are splitting into 80-20, 80 going to train set and 20 going to test set. We chose the 80-20 after experimenting with different ratios, and we saw that 80-20 gives us the best outcome. Now, our dataset is a binary classification dataset, meaning there are two labels, one and zeros. So our label one basically denotes a loan is given, and our label zero denotes loan is not given. Our point of focus is label one, because we want to see that if we want to give a loan or not. Now, we can see that we have chosen precision over accuracy. The reason is pretty simple. So let's say our data set, our non-loan is significantly larger than our loan, almost 9 times as large. As a result, running accuracy in a highly imbalanced data set won't give us any fruitful result. The accuracy value we will get from this particular data set won't basically make sure that, okay, let's say we get a high accuracy, that doesn't mean the model is working very good, and vice versa. So we have to choose anything from recall or precision. We chose precision as a primary metric. Now, higher precision means lower false positive. Why do we need a lower false positive? So let's say we are working with loan, giving out loans. So our target is basically label one, as previously said. So let's say we don't want our label one. We don't want our label zero to be labeled as one. So we don't want our not loan given label to be treated as loan given, because if you give out loans to a person who we shouldn't give out loans, then basically there is a chance that they cannot pay the loan back, and our bank will default. Hence, we want low false positive, meaning we want lower chances of not loan given to be labeled as loan given. Now, these are the models we have used. Uh, we can see that precision is the primary focus, as said before. So we are comparing the precision of different models to say which model is better than the other. If you see that our random forest has performed better than decision tree, because this is because random forest is a bagging classifier decision tree, meaning it takes multiple decision tree and votes on it, and hence it gets a superior outcome. We can see that KNN also performed very good. This is because we have normalized the dataset. As a result, it worked in favor of KNN. We can also see that as we support vector classification tree and logistic regression perform more or less the same. The reason we use SVC and LR is because we are working with binary classification, and these are binary classifier. So as a result, this gives expected performance. Now we can see that LR perform noticeably lower or in terms of precision compared to the first four classifier models. Uh, and finally, we can see the naive Bayes perform very poorly. This is because naive Bayes considers conditional independence between features, and our data set is from the real world. And in real world, features are interconnected because to get a loan or not loan, our features must interact with one another. As a result, naive Bayes perform poorly. So that was all from our project. Thank you for watching.